Hello and welcome everyone. In this video, we're going to be taking a look at electric current. And I'm going to be starting from the absolute basics. So I'm going to make sure that each section builds upon the next. And the sequence of these sections is displayed right here. So then, let's get right into it.
Polarity is a property of matter. And what I mean by property is that it is one of the ways in which you can describe matter. So, for instance, if we take a car as an example, you can say that its wheels are 4. I can say its color is equal to red. I can say whether or not it is an EV, an electric vehicle. So I can say it's true. Stuff like that. You get the idea. So polarity then would be having a value, and the value that a polarity can take comes in three forms. So it can be positive, it can be negative, or it can be neutral. So that's what polarity is. Now we'll move on to the concept of charges, electrons, and holes, which we'll cover in the next section. A charge or charges are particles with a positive or negative polarity. Now, polarity relates to the previous section where we discussed that it is simply a property of anything and that anything is particle or particles for this case. Now, an interesting phenomenon associated to charges is that like charges always repel each other, and so if you have negative negative charges here, they are always going to repel each other. There is going to be some sort of a force that keeps them away from each other. And if you have opposite signed charges, so if you have plus, minus charges, then these are going to attract each other like this. And this is due to an electric field that stems from each of these charges. Electrons and holes are negative and positive charges respectively, and as you can see in this diagram, electrons orbit a nucleus, and when certain conditions are met, these electrons are able to move freely given that they are inside of a conductor. Now, a conductor is simply a material that allows these electrons to move freely within it. So, if you have, say, this conductor with a bunch of electrons on one side, and if these electrons were to move to this side, they would leave behind in an instant some sort of an empty space like this. And because these electrons are no longer present in these spaces would then lose their negative influence, and hence they will gain some sort of a positive polarity. These negative spaces, when they lose their negative influence and become positive, are then known as holes. Electric charge is the flow of electrons from one point to another. Now, this terminology is not to be confused with charge, which was, as you remember, just a particle with a negative or positive polarity. Now, if you have a point A a point B and some sort of a conductive path, say a copper wire, and if you have a bunch of electrons in point A and they were to move towards this point B, then we say we have electric charge. This electric charge is always measured in coulombs. Coulombs. And the symbol is C. So for example, we might say we have 10 microcoulombs or even 50 coulombs. Now that we know what polarity is, we know what charges are, we know what electrons and holes are, and we also know what electric charge is. We can now safely define electric current as the rate of change of electric charge. Now, this is useful because if you wanted to find the current at an instant, say at t is equal to 6 seconds, and we say that at 6 seconds we had a change in Q of say 4 microcoulombs, then we simply plug in the values into our equation and we say, okay, the change in coulombs was 4 microcoulombs, and the time that passed, so the difference in time was 6 seconds. So then we calculate this as 4 microcoulombs divided by 6 seconds, and we get 6.667 times 10 to the power of minus 7 amperes. So current is always measured in amperes. Its spelling is this, and that is how you calculate current.